Now, a lot of you don't actually know me. I don't want to talk about myself too much. I live in the UK. And I've actually been doing a lot of plugin development. And when I started off, I couldn't really find anything that sort of showed good practice. There were just basically documents, a couple from the Gradle docs. And the rest you sort of had to figure out, and I had to sort of speak to Luke and things like that. Because at that time, Luke was still actually in London, so it was good to actually have contact with him. But one thing led to another, and I thought, oh, it would actually be good if we can actually capture a lot of these practices if we do and present some nice kind of idioms. And this is where it actually all started. Now, a lot of the plugins I've done spreads over different kind of things. I mean, I've done a lot of sort of the weird plugins, plugins for like integrating Idiomatic, doing Doxygen for documentation with native stuff. And I got involved with the JRuby plugin, and actually we wrote a couple of plugins to actually integrate JRuby and also ASCII Doctor. If you haven't used ASCII Doctor, it's something I would actually recommend looking into. Yes? Sorry? Oh, okay. So there's a whole bunch of them. Typically a couple of plugins I do sort of spin out tend to be sort of the ones that covers cases you wouldn't normally find. I've also wrote a language plugin for the Myra language, if you ever come across Myra. It's like a Ruby style language for a JVM, but it's one of the few that you can actually compile that doesn't need an extra runtime when you actually use it on a JVM. So that itself was actually part of actually creating a book on the topic as well. Anyway, there's always a lot of things that's interesting in a conference, and one of my highlights this time wasn't actually something technical, but was this. I don't know if you've seen it. So the other day, yesterday I tweeted about the renaming of actually calling it Gradle Build Tool as GBT. And then we got this other talk, after the other tweet that comes out and says, oh, you should call it the lovely Gradle Build Tool, which becomes LGBT. And then Gradle fan came back and actually posted this little picture, all in rainbow colors. And I thought, oh, this is actually really great. Because in the Gradle world, we like diversity. We like to try different things. And we don't really care what your language orientation is. We want to accommodate all of that. So all of this kind of things we do. I mean, we have this very stoic Java kind of guys. They're very stoic. They're very conservative. We accommodate them. And then we've got this like, we've got these groovy guys, you know. They are really absolutely like bi-typed. Okay? And we accommodate them as well, and we can have all sorts of kind of things. And even if you support like a minority language or something, like that, we in Gradle actually like to be able to build that stuff. So we would like diversity. So I thought that was a really good start to have things. Right. And so we're going to carry on now. I hope you're sort of still awake. It's late in the afternoon. I hope none of you have actually stayed up to watch the season finale of Goodbye Britain. But I can guarantee you should actually watch the next season because it will probably be very, very dark and full of conflict. Okay. A little thing, this presentation was actually completely written in ASCII Doctor. It's styled with Real.js and it's built with Gradle. So we've incorporated the whole thing. And some of the snippets you will see in here are also actually tested. So this actually snippets comes from the book I've done. And all of that is tested as well. So there's not actually code that's on the slides that should fail if you try to use it. And the other good thing that you can try before we go into code is there's this little Twitter account called the Daily Gradle. It tweets one tip a day in the week about something about Gradle. And on Fridays, normally we'll tweet something about a plugin. So you get actually a good feedback of different kind of things that's happening in the community. But it's not literally news, it's physical, practical things that you can try. So if you're interested in that kind of thing, you can actually follow. There's not a high volume Twitter account, so it's not going to flood your whole tweet stream. Right, so as I mentioned before, one of the problems is this. I couldn't find a consistent way that you have to write a plugin in. And there is still not very much on this topic, so this is what we're actually going to look at. And the first thing in anything in a DSL, and this is actually sort of covered as well this morning when somebody talked about Kotlin DSL. and it was covered yesterday as well. It's a common theme, is that there's certain things that a DSL that's important. And the first thing is readability. And this is probably one of the core reasons that Gradle came out of Groovy, is because of the readability of that. And Cedric used a very good term. He talked about syntax pollution, and having too much punctuation in it prevents the things being read easily. So this is what makes Groovy great. I'm still a bit reserved about Kotlin, and I will still probably make lots of comments about it. And I'm very, very actually interested in following how it develops. But problems with DSLs, it has to be readable. You want it to be consistent. So if one person writes a plugin, another person writes a plugin, you sort of want them to follow the same kind of style. Otherwise, the learning curve is a lot harder. And obviously, you want them to be flexible, because if you have to do something which is out of the ordinary, you want that flexibility to be able to do that. And this is one of the reasons where Gradle absolutely excels over Maven. Is anybody who uses Maven know it works very, very well for its context, but try something outside of what it's intended for, and you're in Maven hell. So this is also the kind of things I love about Gradle. And obviously you want to be expressive. So if I read a build script, it needs to read like English. I want to sort of understand what's going on, what was the intent of this build. I don't actually want to read code. So this is kind of things, if you write a plugin, you actually want to present this. And we've heard a term being used, DX, at this conference, the developer experience. I've heard it called the programmer experience before. This is very, very important when actually writing a plugin, because what you're actually going to give is you're going to give DX back to that person who actually has to write a build script and use your plugin. And you want to make it as easy as possible for them. Right. So if you never written a plugin, and this is your first time, this is a good place to be. The typical layout that you need is something like that. And I'm going to stick to writing plugins in Groovy, not even Java, because it's quite expressive. And on the other hand, writing plugins in Kotlin is pretty much new and not quite mature. So if you start out on plugins today and you want to get things done very quickly, I still suggest you stick with Groovy for now. The layout is pretty easy. You just have to drop a file into a meta-inf, which you're going to get to, and you have to structure it typically as source main Groovy and put your source code underneath there. And then normally you would use the wrapper. If you don't use the wrapper yet, you should be using the wrapper, especially for plugins. Okay, so your build script typically starts off with being something like that. Apply the plugin for Groovy, use local Groovy and Gradle API. And obviously we're going to talk about testkit later, so we can probably stick testkit in there if you're in a late enough version of Gradle. And I like to test with SPOCK rather than anything else, because it's actually very, very nice and expressive. So we will put in SPOCK as well there, but we need to put in Groovy all, because we don't want the current dependency, transitive dependency that SPOCK pulls in, to actually clash with the one that Gradle API, or actually local Groovy brings in. So that's where we'll always actually exclude Groovy all. Now, if you've been with Gradle a long time, you would have noticed that the Groovy version changes. And SPOCK actually also tracks sort of the, not a major version, but a minor version of Groovy as well. So it will, if there's 2.4, it will always be SPOCK like 2.4-2.3, something like that. Now, this means if you upgrade between certain versions of Gradle, the version is going to change, and you have to go change your Gradle script. But you don't have to do that. If you do the following, use Groovy system, which is effectively the version of Groovy that's running the same as local Groovy. You can pick up the Groovy version and just replace that, and that becomes your SPOCK version, and you can just use it like that. And that's done. Then you don't have to worry about it again. So if we'll go to Groovy 5 at some stage, and there's a SPOCK version for Groovy 2.5, your build script will still work. Then we also get the basic other thing you will do is to create a plugin class. Now, if you've started working with the new model, you will actually know there's also different ways of doing it, but actually creates things that extend rule source. But even then, having a effective top-level plugin class is still a very good thing to do, because you can actually structure the way that your rules gets applied in as well. And your main plugin class is actually the thing that binds everything together. So you always have this kind of structure, and you just have to create a method apply inside it and handle the project class and everything that gets passed to it in. The second thing you need to do to start is to actually create a properties file. And in the properties file, you have to do a couple of things. The name of the properties file, like Idiomatic or for example, is actually the ID that you're going to apply. So if you apply a plugin in this a.b.c, that file is called plugin/a.b.c.properties. The second thing is actually indecided. You'll have to say implementation class equal, and that's the actual class the plugin is going to apply. So in this case, if we go back, my class was called my example plugin inside that package, and we will actually put it inside there. That actually gets us out, and that actually allows Gradle to pick up the plugin when you say apply plugin. An important thing about plugins is when writing is no, you don't have control over which order your plugin is going to be applied in. So you need to make sure if you do certain things in there and it depends on other plugin, you have to force the application of that plugin. Otherwise, you have to make sure there is no dependency. You can safely be applied in any order. So never make any assumptions about which order the plugins get applied in. Another thing that comes to mind is always compatibility. And compatibility, there's sometimes a bit of discussion about it. But in the old days in Gradle 1.x, you had to at least make sure if you want a widest range compatibility to work from JDK 1.5 up. Luckily, most people are away from that. And today, Gradle only supports 1.6 as a minimum. So if you did anything for Gradle 2, you always had to support Gradle JDK 6 as a minimum. However, obviously, if you write a plugin that needs functionality that comes out of a later version of the JDK, then you have to explicitly state on your documentation that people know this plugin will only run with JDK 7 or JDK 8. And there are a number of cases where this is now happening. It's up to you to make that call. If you want the biggest range of compatibility, try to build with 1.6 or build it with that source compatibility. Otherwise, explicitly state so we know. It just makes your life a lot easier. The old thing we used to recommend is build plugins with Gradle 2.0. But that is changing because we can now do better than actually take a later version of Gradle, because if you have proper compatibility testing in place, you can test against older versions. If you're going to work against writing plugins for the new software model, I would recommend not trying anything lower than Gradle 2.12, because it's only at this point where it's really, really becoming useful to a great extent if you want to write your own plugins. There are some ones that's been written earlier, but there's always new things being added, and my experience in the moment is that 2.12 is at least the minimum baseline. Always try to, for me, is always try to keep an older version of Gradle and be as much conservative as possible when you write a plugin. It just solves a couple of problems. But if you know you have to use new functionality and you know it's not going to be supported in certain versions of Gradle, explicitly state it in your documentation. The next thing we actually get is in your code, in your build script, you have to normally specify this, because there was a bug for a long time in Gradle where it didn't actually pass the top two things, the target compatibility and source compatibility, down to the compilation tasks. And you always had things with the major, minor number, mismatch, etc. So normally, you have to do this unless you use Gradle 2.14. It's finally been fixed. Yes. So, right. So remember that. The other thing is obviously set. We've spoken about the version you're going to build, so you're going to set it in the Gradle properties file. I mean, you can use Gradle wrapper to set it, or you can just manually edit it. I just find it easier. I mean, I'm an old school person, so it's easier for me to fire up just VI and change it to actually type something else. But that's the kind of things you have to remember. Now, the most important thing that drives most things that happen in any kind of build tool are tasks or targets. So in Gradle, tasks are effectively the main cornerstone of getting things done. And this is the kind of things I want to focus on. I don't really want to focus on styling of like the new model of too much around other things. In the end, the things we're going to talk about tasks apply to both old model and new model. So in tasks, the first kind of thing is try to always provide a default instantiation of the class. That means that somebody doesn't need to go create your class explicitly. There should always be at least a default version. For instance, in the ASCII Doctor plugin, there's a task called ASCII Doctor. It makes sense, it's got the right name, and you don't have to do extra stuff, you just have to go and configure it. But keep in mind that people actually might want to do extra tasks. So give them the flexibility to create same tasks with other names of the same type. Now, the bin tray plugin, for instance, is an example of a badly written plugin because you can't create extra tasks. The moment you create a task, you think it's work, you reconfigure it, and then suddenly all of the values get overwritten because they use the way of actually using the extension to try and write things into the task. Don't do things like that. Don't give unsurprising behavior. So one is just make sure it's the default instantiation, and secondly, allow people to create extra tasks if they need to. Now let's look at a simple case of creating a task. There are various ways you can do a task. You can extend from specific other kind of tasks if you do extension, but in many cases, a lot of tasks simply extend default task. And then you have to create at least one method in there, which you annotate with task action, which is the one that's actually going to, the method is going to be called when the task actually gets executed. That's your basic things. We will actually look inside the properties just now, but there's a very, very important thing, and this is really one of my bugbears. And this is what I call on or offline. If you use Gradle a lot, you know it's got an offline switch. I travel a lot. I do a lot of work where there's no network connectivity. It is a pain to work with a plugin that doesn't know about it, because suddenly your builds break because it can't work offline. So it's important to write your plugin so as far as possible be able to do something useful or disable itself if it's not online. And it's pretty easy to do. The simplest case is simply to have something that sets the enabled property on any task. And you can do it in the constructor of the task. And normally all you have to do is traverse down the project task, the project object, go to the Gradle object, find the start parameter, and check if it's offline. And you can actually set it. Makes your life a lot easier. For instance, this is the VFS copy task. It copies things from remote file systems. And this is not something I want to run if I'm offline, so this task will actually automatically disable itself, for instance. And it at least gives a good experience to the person who actually is using the plugin. Another thing you should probably look at is, instead of writing properties as members of tasks, is to use methods. I mean, Groovy gives you this wonderful thing of just declaring a property and you get getters and setters. Unfortunately, there are reasons that doesn't really work well with tasks, because you want to, it sort of detracts from a nice DSL. And we're going to look at it. And other reasons for doing the kind of methods is because you can have lazy evaluation. It's easier to override default attributes, etc., and it reads just a little bit better. Now, obviously, if you're going to do new model, lazy evaluations maybe not that important, but configuring tasks is generally still something you're going to do a lot. So we're going to look at a basic case, and one that gets done a lot is a collection of files. I mean, there's a lot of tasks there that has to do a thing with collection of files. Now, the simplest case is to do that is to create a list of file and as a name, and you annotate it with input files. The problem with that is it creates you have to do something like below in the DSL. Now, already you have to put in square brackets and a couple of other things, and you have to put an assignment, and you get this kind of noise, punctuation noise that's arising there. So we like to get rid of that. So if we do the following, or before we actually get it, we really want to be able to do things like that. We just want to say that's the name, and I would do a couple of things. I want to specify a list of things that it should append it, etc. I want to give it a closure, and it should just add that lazy evaluation in there, etc. Actually, I want to stop at one point here. There's a second line in there. It says new, my source is new file path to foobar. We would like to do that, but it's a reason why many times you don't want to do that. Does somebody know why we don't want to use? We should prefer using file over new file. Yes. Okay. So I'll repeat that. So the problem is if you don't do that, if you use new file and it's relative, it will get reference from the path that a daemon actually runs in. So you might have some strange behavior, you don't know where it comes from. So keep that in mind. So generally just use file as far as possible. And if you have to do, I mean, file has got a nice constructor where you can pass two paths in it. Just make it a G string in the build script, and it will solve the problem as well. Okay, so this is what I like to do. That reads a lot better, and I'm sure you agree with that. So what we're actually going to do is we're going to ignore the Groovy shortcut, and we're actually going to put 3 methods in there. We're going to give it the normal setter down below, which actually, if you write to that, it overrides everything, which allows you to actually reset any existing default assignments. Then we're actually going to put a second method in, which is the one in the middle, which allows you to append. Well, actually, I've got it the other way around. The one in the middle is the assignment. The one at the bottom allows you just to append. So that gives you a sequence of actually be able to write things on many lines and just pass in values. For instance, if you pass arguments to a Java exec, that's a good example of that in action. And then what you actually do is we actually annotate the getter, and the getter then gets set as input files. And what we also do is we don't actually store them as list of file, we store them as list of object. And then we use this magic function on the project object called files, and it will actually take care of handling all of those things for you. So you just use effectively what I could call the magic of Gradle, or the support it has, and it will take care of closures, it will take care of lists, etc. So irrespective of how you do that. So, and also it does at the very, very last moment, only when it gets used. So you get very, very good lazy evaluation. Now, there's a lot of task annotations that you can do, and this is one of the things you should do, is actually really familiarize yourself with them. There's a couple on input, a couple of output, and these things are actually things that help Gradle determine when it's up to date or not. So it evaluates your task. So if you're going to put fields in or methods which are annotated, which do not actually get annotated, Gradle cannot know when it's up to date. So it is very important that you know about these and go read about them. I just want to highlight one at the bottom, which a lot of people don't know about, is nested. Sometimes you have this kind of thing is you want to share code, or you have an object which you can share between kind of things. Normally you would have to put everything in sequence in the task. If you create a separate class and you put annotations on it, you just put that class in your task and you can put nested on it, and it will actually go and evaluate all of the annotations in the other class and put it inside it. So you can actually reuse code very easily in that way. So I'm not going to dwell on each one in here specifically, but make sure you actually know what they are. So let's move to another one, which is also very common, is strings. So, I mean, a collection of strings is something that you actually use a lot as well. It's a very, very common pattern. Now, we can do exactly the same kind of thing. We go for the 3-method approach. And in this case, we're obviously not going to do input files. We can annotate the getter with input. We're still going to store the strings as a list of objects, so we can get lazy evaluation. Now, the bottom two you should be relatively familiar with. And what we actually do is call another magic method. It's in collection utils, and it's called string eyes. And string eyes will take different kind of objects and make strings out of them. So you can, for instance, pass on a file object, and it will toString it. So it does a lot of that work for you on any kind of array, etc. So it's another kind of little function which makes your life easier of writing a plugin, but it actually eventually makes the life of build script author a lot better. Yes? We've talked about it, and Andre Almaray, who you might know or not, we've talked about it as well to do certain kind of things. But finding good use cases to easily make it generic isn't that easy. So we're still thinking about how we can do that. But we have to also think, yeah. Yes, it could be. So.
String and file, like a specific one says.
Yes. So, but if you'd like to write one, it would be great. Yes. It's all Gradle util collection utils. Oh, it's on top there. And right, then we also have another common one. Okay, we do a lot of key value pairs. I mean, setting properties on things which you might pass somewhere else. For instance, if you want to do environment variables, for instance, Java exec task, once again, a very good example. What we're going to do is try to implement. What we don't want to do, once again, is the same kind of thing. We don't want to declare a map, because then we have to do the same old kind of thing, put square brackets in there, and we get pollution. Simply, it doesn't look nice. So let's do this better. With maps, it's slightly, it can actually get a lot easier because we can do things like that. Now you can see we drop all of the punctuation. We can call it multiple times and we'll just add it in, etc. And if we want to reset it, then we explicitly assign it. And like we can do an explicit complete reset, take the default values out if we want to, give the build script off with those kind of things. And to do this is relatively easy once again, but you stick to the, the three method rule. And now we don't have to call any magic functions or something, and that code is pretty straightforward. You either assign or you append. And then when you return, you just annotate that. I mean, you can go more complex than this if you need to do like lazy evaluation and things like that if you want. I can leave that up to your imagination, but this is the basic tenet of actually getting a very good DSL. And if you only do these three things already, you will have a much better DSL. I'll stop there for a moment before we carry on. Do you have questions about this? Okay. We'll talk about a bit about testing. There's used to be a big problem in the past is how do you test compatibility across a large version of Gradle releases, and especially, I mean, Gradle releases are coming out thick and fast nowadays. And it's very, very hard, especially if you're like an open source contributor and you have a couple of plugins. How do you actually make sure these things stay up to date? So, compatibility testing, now we have TestKit. And there's enough people that talked about TestKit. It was added in 2.7. It really, 2.9 is the first one that actually added multi-distribution testing, which is the first really useful feature. But it's only about from 2.12 to 13 that's really, really become useful. So you still have a problem. What if you have to write things for Gradle that's older and you're actually building with a version that's older and you can't use the latest things? There's a solution for it. There's a plugin called Gradle Test. And you can actually, if you apply it, you pretty much do something like that. And that's the basics. And what you'd actually do is a bit different. You create a folder called Gradle Test, and then folders underneath that, which you name as your test. And then inside there, you actually create a build a Gradle file for each of your tests. And you create, in each build Gradle file, you add a run Gradle test task. And then in that build Gradle, you actually write scripts for your plugin. And if you actually, and then all you have to do in your plugins build Gradle is to specify the versions. And when you run it, it will actually go and it will download the necessary versions of Gradle if it needs to, and it will actually run each of these things in a separate JVM. So you still have a whole solution. It's now getting to the point where it's becoming redundant. If you'd like to do, especially from 2.12 onwards, then you probably don't need it. It does have one nice advantage. You actually write something as if you're writing a script. So maybe that will get updated to actually use TestKit in the future. So I'm just leaving that for you. If you still have to do old versions of Gradle, that's a good plugin to use. And actually, the books that I will refer to later were actually all tested across all versions of Gradle using the Gradle Test plugin. Okay, that's a little trick. It uses an internal API, Well, I'm going to use another. So I call this Grexit because we want to take those plugins back and take control of them. There's a lot of internal things that's so useful. And I always annoy the Gradle guys by saying, oh, but yes, I want that thing in the public API. And they say, no, but it's only for us. Well, maybe we want to take all of those things out one day and put them in a separate library. But yeah, that's a great little thing you can try. So for instance, an ASCII doctor, we create directories based upon the names of the backends that we use to create things. Problem is, if you define a backend which has a name which is not compatible with your file system, it will fail. So this is a nice little utility which you can actually put a string in and it gives you a safe file name. So if you have to do something where you have to convert effectively build script input into file names somehow, then this is a nice utility you can use. Or if you really want, maybe somebody wants to take a copy of the code out and create a new little library which you can use separately. But think about this one. Remember this one. And Renee is not here today, so I can't wind him up because he actually wrote the code. And I remember doing this in one presentation, and he went and looked at his computer and said, that was me. So this is just a little thing. There's a couple of these other things that we will do. And but there's a couple of things I still want to go through. So let's look at something about a new model. I mean, I've covered a couple of basic things, which is the ones I think is the things that everybody should do. but I would like to actually just look at a couple of things at the new model. And one of the things we actually want to do is, let's say you're actually trying to migrate your plugin to the new model. And one of the things you might have is you already have an extension on your old way of doing it. So what you would say, well, I don't want to rewrite too much code. How can I do this? So one of the first things we can actually do is we can effectively create a link between the old extension that you've created, and then we can actually effectively make it appear in the model. And let's just have a quick look at this. Let's assume we have some kind of existing extension code which adds support for an external tool. For instance, this one just assigns make. And it has a couple of global arguments that all invocations of running that will have to apply. Normally in your plugin apply, you would do something like project extensions, create, give it a name of the extension and the class. That's why we've always done that. Now, we might just say, let's take one simple step and just make this appear in a new model. So all we need to do, well actually, this is how it would look if I applied extension, firstly. If I want to have it appear in the model, I still want the same kind of things to happen, except it has to be inside the model block. That's nice because it's an easy migration path. People are not too surprised when they have to change and upgrade your plugin. So what you will actually do is effectively only that. You will create a rule source which you will apply, and then you will create what we call a unmanaged model, and then you have to give it the extension container. Now this is something that's not written down anywhere. So, and it's one of those little magic things that happen in the new model, but you can just do that. The extension container gets passed in, and all you have to do is go look in the extension container, find a specific class type that you have, and return it again. And suddenly it just appears in the new model. It's a pretty simple migration path. Now, there's a couple of disadvantages to doing this. One is, obviously, it will now be in the extension and in the new model. So if you make a change in the one, it appears in the other one because it's pointing to the same object. The more dangerous thing is that you have no control over when project after evaluate executes and when the new model evaluates the values. So this could actually lead to undefined behavior. This is the bad thing. The other thing is unmanaged objects are not guaranteed to be immutable in the new model. So you have to think about those kind of things. But it might still be an easy way to migrate, and then your documentation just have to state either use it outside or use it inside, but not both. But you want say, well, I'm a bit uncomfortable about this. Let's try to do something better. So what you can actually do is migrate your whole extension to the unmanaged model without it now appearing in the extension anymore. And this will eliminate those kind of issues of linking, etc. And the only thing you have to do now, you have to start taking care of the decoration yourself, because once it was still an old extension, Gradle will have decorated for you. Now some of the things that you would have expected to be there won't be there anymore. So if we take our existing extension class, which was the top part, we just have to say, for instance, I want to not just do assignment, I want to do more declarative and give it just the word executable and a string which is going to be. You'll have to add that method yourself in a similar kind of way that you might have had to do it in the task classes a couple of releases ago. You'll have to add it, you have to keep that in mind. So if you have a lot of things in your extension, you might have to do a couple of these methods. But once again, you might have done a simple migration, add a method, you still only have to do that. And it will still pick it up. Okay. The disadvantages of this is actually it's still not immutable, and you have to add your own decorations. So this is just a simple kind of start. I mean, a new model is actually very, very complex, and I complain about it all the time because there is too much magic in it still at the moment. And as we are progressing through writing these kind of recipes, still learning a lot about this kind of things. So there's all the little kind of things you want to do. Have you ever considered a case where you're actually writing a plugin And the plugin, the functionality you're writing for that plugin, you actually need in the plugin you're writing. You need to use that, but it's sort of a chicken and egg situation. For instance, let's take the example if I want to write my own plugin to publish to bin tray, for instance. I actually want to push that plugin to bin tray, but I need a functionality I'm writing now, so how am I going to do that? In the old days, you would have written like one version, or you would have published the first version manually and then used the previous version to push it, etc. But there's a way of actually bringing these two things together. We call it a self-referencing plugin. So what we do is you put this little piece of code in your build script, if you have to do this. And you actually apply an instance of a Groovy script engine instead of a plugin class. You tell it where your Groovy sources are, and the class loader, which you can pick up from the project class, and you just say load script by name, and you give it the plugin scripts location. And it actually instantiates that code in your build script. And we've actually used this to publishing, and the Gradle test plugin actually does that. It uses the latest functionality of Gradle test to test itself. So it's one of those little tricks. You might, it's not that applicable to most things, but it's a little thing. If you ever have to do that, this is one way of doing this. And now really, yes. It could be. There are different ways of doing this. This is one solution. One other one might be to do multi-project. One might be to actually do build source. The danger of this one is if you actually break your code. Let's say I left a square bracket or something out in my Groovy code. My Gradle script isn't going to load. So normally I wrap this with a little conditional, which I can turn off via project property if need be, so I can actually at least get a build script to load and do other things. But that is one way of solving a problem. I really wound up Cedric about this the other day because I said, right, I think the Kotlin implementation would be mature enough when it can do this. And he obviously came up and talked about a lot of things, but that is just one of those little tricks that you can do. So we got a couple of minutes. We might do a couple of extra ones. So firstly, there's 2 books on writing plugins with status there. The green one is complete. It's got 25 recipes which you can effectively use today. Some of the things you sort of seen in here is explained in there to great more detail. The red one is under construction. It's got 4 recipes in it at the moment. So if you get it, you can just get the updates as they go, but they all focus purely on the new model. And obviously getting that written is a lot of learning for myself as well. I love feedback, and as we get feedback, we actually update the books as well and push them again. And these books, as well, the green book has been tested from Gradle 2.0 through to 2.14 in a moment. So we know everything works. For instance, we picked up some of the recipes broke when Gradle 2.12 got released. So the book got published again with updates for that as well. So there's the link. It's easy to find that. But I think we've got a couple of minutes. I think 6 minutes left. Right. I am going to skip over that. Right, I've got a couple of other ones. Is there anything in those 4 that anybody wants to see? So we'll have a vote. So we've got a couple. We can actually look at how can you override existing library versions so that a user can specify its own library when it does something. How can you actually decorate existing tasks that somebody else applied in a plugin and your plugin actually decorate that task? Or how can you actually add a generated source task? Anyone want to have a go? A vote for generated sources? Okay, so let's go to generated sources then. Let's see. And this is what I love about Reveal.js. We can just skip over everything else. Okay, so this is an example where this is actually sort of changed in the JRuby jar plugin, but this is one thing that we did there for a long time, as we actually wanted to annotate the jar task with additional information, but we didn't want to create a separate jar class type. And this is actually a very good way to also create like sort of generative programming environments. But pretty much what we're going to do is, are we the right one? You said jar. Sorry, this is the right one. We can actually generate additional source sets We're going to add them, we're going to generate a code, etc. And then we can add them when they get compiled. So the first thing you want to do is you want to create some kind of generated task. In this example, I'm just going to use the copy task as my generator, which is going to copy something from a template, modify it, then create some source, and we can add a directory where those sources are into the source sets. And then we can add appropriate dependencies. So let's start with the basic generated task. There's a lot of things down there, don't worry about the bottom ones yet. But first we are going to do is create that generated task, and then we're going to configure the rest of the things. So the generated task in itself, all we have to do is is to create an extra object, an extra task, and then we configure it. It would be nice when you do these things is to add your group and description, so if somebody run Gradle task, they get a proper description, so don't forget about that. Then we're going to say, we assume, for instance, in this case, that the sources live in template Java, because we're going to copy Java code, and they call something starter java.template. And then we're going to copy them during the build phase to generated Java, and then we're going to run some kind of generated there. This one is simple, it's just going to substitute some tokens. But it's going to create us some Java source in that directory called builder generated Java. Okay, that's pretty straightforward. What we now need to actually do is add a generated code to the source set as part of the plugin. And what we will do is simply to say, let's look for source sets that are part of main, and then we simply add generated Java into that source set. That one actually still use new file. It sort of gets away with it because builder generally tends to be an absolute path. It should really have used file. But that's a easy way now. So suddenly your generated code, which ends up in builder, is part of your Java compilation. And then all you have to do now is to make sure that when the compilation task was to run, it has to ensure that the source code is there already. So all you have to do is check whether the tasks are there, and this is quite important. This is where the thing applies that you don't know which order plugins get applied in. So you need to take care of both of the cases where your plugin gets applied after the Java plugin or before the Java plugin. Kind of thing. So that's why we actually do two kind of things in there. We say if it's an instance of, well, actually, get my name. Actually, we got to. Sorry, I'm skipping ahead of myself here. We are lucky in this case because we know Java is going to be applied, so we can force the Java plugin to be applied before this happens, so we don't have to check that. But in many cases, you have to do this. You still have to ask the when task added, and pretty much what we're going to say in there that is my task maybe is called my generator. When a compile task gets created, then we simply create a dependency link between the compile Java and my generator. Now it will force the code to be generated before the compilation happens. Yes. You could possibly do that as well. There is more than one way normally to solve this problem. When task added will fire when the task gets added. If it doesn't get added, which is the first case really, it says if it's there, then we depend on it. So this is how this one says get by name, it will find it. But when task added, you can't use it after the task already been created. Yes. There's our solution. Your question answered? Or are you still confused? I'm not sure if that's changed. I don't think so. No. Okay. Yes, there's a couple of ways. So you can find something that works for you. The most important thing is to make sure that you handle the case of plugin order independently. You are safe in that cases. Right, so that's pretty much everything. Once you've done that, you've got a linkage, you can actually have generated source code as part of your source set. And that is pretty much it. And I think we're pretty much on time. So thank you very much. Important thing is keep those DSLs extensions. Keep them beautiful. And don't spring surprising behavior on the users, because we are going to hate you for that. If you want to get hold of me, there's my details. If you want to tweet about this kind of style, just use Idiomatic Gradle as the hashtag. Thank you very much.